All right, now this video is going to talk about making, drawing a line of best fit for when you have a scatter plot. So we'll do I'll try to do like one or two, like more than one of these. So in this example here, it's showing weight and fuel efficiency for 12 vehicles. So on the right, or not the right, but on the x-axis, right, that's your independent variable, and that shows the weight in pounds of the vehicles. And then the dependent variable is the fuel efficiency in miles per gallon. So for example, if we look at this, that means if we look at the second point from the left, you have a vehicle that's 1,500 pounds, and its fuel efficiency is around, I don't know, 43 miles per gallon or so. And you can see that as the weight of the vehicle goes up, the fuel efficiency drops, right? And so when we make a line of best fit, basically we're just trying to put in one representation, one line that represents the overall idea of what's graphed there, right? So to do that, and it's kind of tricky on ALEKS. It's a lot easier to do this on pencil and paper. But on ALEKS, what you got to do is you got this line tool, and you got to take this, and you got to, I suggest taking this first point and kind of putting it sort of in the middle on the left side. And then you take this other one, and you want to position this, right? You don't want to put it up here because almost everything's under it. And you don't want to put it here because almost everything's over it. You want to put it so that it kind of splits the data in half, so that everything is as close as possible to that line. So this is what I would do. I would go with something like this and say, okay, yeah, that looks like that kind of goes right down the middle of it. And then click check, and yeah. All right, let's try another one. So this one, again, it's going to be a negative slope, right? It's a negative correlation, so we're gonna do what we did before, and I'm gonna go kind of, I don't know, let's go right here and see how that looks. And sometimes you gotta fix them a little bit. And so if I go like there, you can see I have like maybe one or two more values under the line than I do over the line, but this isn't terrible. It would be better if I could move this first point, you know, maybe down one, I don't know, then move that up, I don't know. That's maybe a little better, right? But they're close. Okay, so let's, this is not, that's why it says it doesn't have to be exact line of best fit. I'm sure there's a way to actually do that and show that, but when you're doing it, it's just a matter of, can you get the idea? All right, this one, same thing, except that you have a positive relationship. So you can see it's gonna kind of wanna go right along there, right? If you look at the orange circle thing, that's kind of where we want our line to go. So I'm going to put this one there, all right? And then I'll grab this, and we'll put this, I don't know, let's put it maybe there. Yeah, I think that looks okay. Let's go with that. And so that's how you do this, all right? So it's not completely, it's not very precise necessarily, but if you can get it kind of in the area, and that's why they say you're kind of approximating it, then you're in good shape. All right, so good luck with this.